Hi everyone, welcome to this channel. In the previous session, we discussed about the introduction to the Internet of Things and then devices endpoint for the Internet of Things. And then in the unit 3, we discussed about the sensors and connectivity. Now we are going to know about the design methodology for the Internet of Things and some of the case studies related to the Internet of Things. In the design methodology, you are going to know about the purpose and requirement specification, and then what is in which purpose you are going to designing the IoT system. And that means the design methodology consists of 10 different steps. Under the 10 different steps, first step in this case here is the purpose and requirement specification for the IoT system. And then second step, the process specification. The process specification, under the process specification, you are going to draw the use case diagrams. And then the domain model specification. What is the domain model specification? How can you define the domain model? And then in this case, you are going to draw the some of the class related. That means you are going to defining the different entities and then the entity related information. And coming to the information model specification, one of the very important model. What is the information model specification? How can you define the information model specification? Like that, you are going to know some of the information regarding the information model, and then service model specification, and then level different level specification. In the unit one, we discussed about the 6 different levels for the designing any IoT system. That means you are applying all these levels in this case. And then functional view specification, operational view specification, and then device and component integration, finally application deployment. Based on these 10 related steps, you will apply these 10 related steps for the home automation system and then smart cities. This is a unit 4 discussion. Okay, thank you. Okay, in this session, you are going to know about the IoT design methodology. What is a IoT design methodology? The design methodology or IoT design methodology consists of different steps. The first step in the design IoT design methodology, purpose and requirement, and then second one, process specification, domain model specification, information model specification, the service specification level, and then functional, operational, device and component integration application. Those are all different things. Here, what is the purpose here? Here in this case, you will define the in which purpose you are going to designing the model. Here, what is the purpose? In which purpose you are designing the this IoT system? That means purpose may be, for example, home automation, or it may be a smart cities. That means for example, a smart lighting. That means in which case you are doing that information. That is a purpose. You are coming to the requirement. The requirements may be different requirements. The hardware requirement, software requirement. Here for designing any IoT system, what are the device requirements? That means you have to gather all these requirements here. Coming to the second one, process model. What is a process model? In the process model, you will define the use cases. What are the use? What is the use case? Use case specifies the action. The use case, that means that means before that, before domain model, you have to draw the use case diagrams for the IoT system. For designing the IoT design model, you have to draw the use case diagram. Now, based on the purpose as well as the requirements of IoT system, here you are writing the different actions. For example, ATM system, enter into the ATM, insert the card, and then taking the money. These are all different actions. For the system, these are all different actions. Yes, similarly, for designing any IoT system, for example, smart home appliances. For smart home appliances system, you have to write the use cases. That is a simple information. Coming to the domain model specification. Here, what is a domain model specification? In the domain model specification, you are defining the physical entities. The entity here is a called as a real world thing. The entity you are defining as a real world thing, and then the entity may be, for example, how can you represent the entity here? The simply representation implies an entity. Student is an entity. That means the difference between a class and entity, the student attributes, class having the attributes, the student, the entity having the attributes, and then this particular class consists of attributes as well as the some operations. Here, those are all called as a state. Here, it's performing the different states. That is a simple entities, and then it consists of virtual entities, the virtual design entities, and then some of the devices you are using. The previously you discussed about the devices, IoT devices, different types of devices you required. What are the devices you required? The devices simply call it as a different nodes. Here for these nodes, what are the information you required? And then resources. Resources is a software component. Here in particular resource, it takes the information from the device, transferring that information into application. And then these resources, not only these resources, it is having the services in a IoT system. That means all these information represented in a domain model specification. Coming to the information model specification, the second important and then fourth important one, information model specification. Here in the information model specification defines the structure. The structure may be a relationship and attributes. The structure in the sense, in the structure, you are defining the different tables. The table consists of rows and columns, different rows as well as the different columns. Attribute is a property, the property of structure or table. The different attributes, employee number an attribute, employee name is an attribute. That means in this information model specification, you will defining the tables. That means what are the data you are going to storing on the table, and then different attributes for the tables of all information in the IoT system. Here, that means the everyday sensor generating the different data. Where you are storing the data? How can you creating the table? How can you store that information? That kind of information done in a information model specification. Now, next important one, service specification. Here, what is a service specification? The services in the sense map process. The map process and information model to services and to define the service specification. Here, this information model. Here, you have to map the process model as well as the information model. Here you are mapping the process model. That means process model is a second model, and then mapping. There is a mapping between a process model as well as the information model. That means it's a leads to the service, and then here defining the different services. That is a simple representation of service model. Next, sixth model here is a IoT level specification. IoT level specification. You have idea about the different level. In the unit one, I explained about the six different level. Level one, level two, level three, level four, level five, level six. Six different levels are there. one IoT level, for example, IoT level 1, all information you have the storage in a local system, and then application is a local based application. For example, home automation system by using level 1. But here you are not touching the cloud based information. Coming to the level 2, in the level 2, the storage is a how can you store the data? Data is a cloud based storage, and an application is a cloud based application. That means you will store the data onto the cloud. Why? Because the level 2 templates always generating the large amount of data. These type of systems always generating the large amount of data. That is the main reason you are using the cloud based storage. That means it's stored the why? Because cloud based storage, the cloud based storage is scalable storage based on the, that means depends upon a requirement, it will scaling up and scaling down. That's why you are using a cloud based storage. Here in this case, coming to the another important one here is a level 3. Level 3 also same information, but some information existed, that information, that means here also use the cloud based, here also use the application as a cloud based application. And then level 4, similarly level 5, and then level 6, different levels are there in this. IoT level specification defines the IoT level for the system. And then the next important one, the functional view specification. Here the functional view specification map the IoT level to functional groups. Here there is a mapping process is there, mapping the IoT levels to different groups. And then operational view specification. Here what is the operational view specification? The very important one, it defines the communication operations, the service hosting options, and then storage options, and then device options, all are represented in a one place. That is a operational view specification, very important component this one. How can you represent the communication? That means one device to another device. That means the communication, how can you send the data, how can you analyze the data. And then service hosting options, some of the storage options are there, device options. That means all here defines the communication, service hosting, storage, define options represented in a operational view specification. Coming to the ninth one, here is a device and component integration. Here in this case, integrate the devices, deploy and integrate the components. Here you will deploy and integrate the different components. That means you are writing the code in a different components. Here in this place, that means for example, if it is a device, the device software you are writing in a for example C++ programming, or some, for example, some C++, for example Ubuntu, not Ubuntu, that for example, if you use the Arduino, you are writing the C++. If you use the Raspberry Pi, you will write the device software. You will use the Python programming. Here, all placed in a one certain place. And then, if it is a communication software, the communication software you are writing in a Java programming, or any Python programming. With the help of Python programming, you will write. Here, all that information aggregated one place. That means integrate the all devices, deploy and integrate the all components one place. That's called here device and component integration. That means here you will integrate the all information. And then coming to the application development. Here finally you develop the application. This is a the design steps. That means later you will discuss each and every one by one. The step one. What is the purpose of step one? What are the advantages for this one? That means next you will discuss about the one, step by step. Okay, ma. Thank you.
Hello everyone, welcome to this channel. In the previous session, we talked about the IoT design methodology and case studies. That means you discussed some concept related to the design methodologies. What are the design methodologies, and then what are the steps for design methodology? These are all 10 different steps for design methodology. That means you discussed these concepts. Now you are going to know about the elaboration of the all design methodology steps. The first thing you have the first one, requirements specification. In the requirements specification, we define the purpose and requirements of a IoT system. Here you are going to designing the IoT system. In which purpose you are going to designing the IoT system? The purpose may be, for example, in case of home automation system, what is the purpose? The purpose may be monitoring the lights. And then in case of smart cities, what is the purpose? The purpose may be identifying the vacant place for the smart parking. Like that, that means you have to define the purpose in this case, and then requirement for the IoT system. Similarly, process model. In the process model, previously discussed use case design. That means you are going to design in the use cases, and then domain model. In the domain model, you will define the entities for this one. And then information model. What is the information model? In the information model, you will define the structure of in this system. That means that indicates that different attributes as well as the relationships. And then that is a simple representation. And then coming to the next important one, the service specification. What is the service specification? In the service specification, mapping process. This is a mapping the process model specification to information model specification. The mapping of process model specification to information model specification, that is called here service specification. Based on the mapping here, you will defining the different services. That is a simple information. Already discussed the concept. And then IoT level specification, you have a 6 levels for designing any IoT system. That's called here deployment template for the any IoT system. And then functional view of a system, operational view of a system, and then device and component integration, finally application development. You discussed those concepts. Now you will discuss one by one. Here, what is the purpose and requirement specification? In this case, you will the methodology. This is a first step in IoT system methodology. That in the design methodology, this is a first step. In this step, you will define the purpose of the system. In which purpose you are going to designing the system, and then the requirement of a system. That means you will define the behavior also. The behavior, for example, in the home automation system, if you consider the home automation system, the behavior indicates the different modes, performing the different modes, and that means automation mode, and then like that the behavior of the system. And then requirements. Here you are collecting the different requirements, some of the data collection requirement. At the time of collection, you will identify that means for doing that one, you require some data collection, data analysis requirement. Analyzing the data is a very important step in a data science. That means you are going to analyze in the investigation of problem based on the data set, or based on the data collection. That means what are, in this case, you are identifying what are the missing information, and then how can you rectify the missing information, and that's a simple information. And then the system management and the privacy and security. That means the data privacy and security is one of the requirement, and then user interface requirement. That means in this case, you are going to capture you are going to identify these number of requirement. That is a first step in a design methodology. Coming to the second step. In the second step, you have to define the process specification. The process, the program under the execution. The process specification means in this step the use case of IoT system. Use case. The use case means the action of a system. For example, in case of ATM system, what are the actions? Enter into the room and then inserting the card, and then taking the money. These are all different use cases. That means in this step, you have to identify the use cases for the system and then derive a, that means how can you get these use cases from the previous step? From the period, what is the previous step? The requirement specification. From the requirement specification, you are going to designing the use cases in this process specification. The use cases represented as a circle. In this case, you will represent the circle denotes the state or attribute. That means this is a way that define the process with the help of use cases. Here, these use cases are described based on the purpose and specification. The second important step in this case is one. That means in this case, you will defining the different use cases. That means how can you defining the use cases based on a, for example, draw the use case based on a threshold value. You will identify the some other information. That means totally you are defining the use cases in this system. The second third important one, the domain model specification. Here the domain model specification provides a abstract representation of concepts, objects and entities. The concept in the sense data collection, object in the sense how can you represent the object, the instance of an entity, the instance of an entity called it as an object. Here in this case entity, here real world, the real world object, that means entity how can you represent, for example employee is an entity, for example student is an entity, for example department is an entity. In the database management system, each and every represented as entity. Here there is a difference between the entity and a class. Classes having the attributes as well as the state, but entity is not having the state, but it's having the attribute. Here the independent specific technology and platform. With the domain model, IoT system designers can get understanding the IoT domain for which the system to be designed, and then it defines some of the attributes of an object and their relationship. Here, the entities, objects, and concept includes the following information. What is the information? It includes the physical entities, virtual entities, device, and then resource, and then service. These are all are the different information on the domain model specification. They are all representing the different information in a domain model specification. And the first important one in this one, the physical entity. What is a physical entity? How can you represent the physical entity here? The physical entity, the discrete, identifiable entity. That means the real world entity. That's called here in the physical environment. In the physical environment, temperature is one entity, pump is one entity, motor one entity, LCD is one entity, the room is one entity, the physical entity that is called here physical entity. The room, that is a this is called here physical entity. The IoT system provides information about the physical entity using a sensor or performing the activation upon the physical entity, like a switching motor on. That means what is the information here? The physics based on that means the physical entity, the sensor takes the physical entity, always take the physical entity information. Is it clear or not? The sensor takes the physical information entity, and then activators take the releases the physical entity. That is a simple information. That means you will represent the physical entity like a rectangle box. In the rectangle box, you will represent the physical entity. That means the real world entity that's called here a room or appliances. That means one is a physical entity room. In case of home automation system, the room is a one physical entity. That is a simple representation of physical entity. The next important one, logical entity. The logical entity means the representation of physical entity in the digital world.
Will you identify that? That means a person, the particular person, employee, Rama is a physical entity. The Rama, that means you are writing Rama as a name with the in a bracket, that is called here logical entity. The representation of Rama. The representation of Rama, you call it as a logical entity. Then that means in the digital world, the representation of physical entity, you call it as a logical entity. The one thing here, for each and every physical entity, there is a logical entity. That means if there is a physical entity, you can identify the logical entity for that physical entity. That means every physical entity having the logical entity. That is a simple. That means for room there is a logical entity. That means room you will represent the as a diagrammatical format. The diagrammatical format you call it as a logical entity. The next important one, device. How can you represent the device? Device is a, let us assume, sensor. Device is a activators. That means anything you will call it as a device. Here, what is a device in this case? The device is a medium for interaction between a physical and a logical entity. Here, for example, there is a physical entity, there is a logical entity. That means, for example, the temperature, let us assume, the temperature converted into digital format. The digital format of is called it as a logical entity. For the corresponding temperature, the physical form, logical format, the digital format you call it as a logical entity. That means this particular medium you call it as a device. For interaction of physical entity as well as the logical entity, there is a one medium is there. The medium we call it as a logical entity. Not a large device. Here, devices are, for example, for the devices, sensor. The sensor is a one type of device. The activator is a one type of device. Sensor is a one type of device. Activator is a one type of device. Here, the sensors are used to gather the information from the physical entities. Here, it is used to gather the information. Devices are used to identify the physical entity using tags. That means this is a very important concept. These particular devices are used to identify the physical entity in a real world. That is a simple information about the devices. Coming to the resource, a device is a one. Let me take device is a medium. That is a here software. How can you represent this particular software? Software here is a, it is a resource. Resource is a software component on a IoT device. For that means it is a, the resource in this case, the software component here. This particular software component you on the IoT device for accessing data, for processing data, storing data. That means storing a sensory data. Here, for example, the physical entity, sensor, logical entity. That means where you are storing this information. For storing this information, there is a resource. That means the resources are used to accessing the data, processing the data, and then storing the sensor information and controlling the activators connected to the device. For controlling the activator connected to the device, you will have this entity. Here, for example, in the home automation system, the resources may be network resources, on-device resources. That means so many different resources available. That means this is a on-device resources. Resources includes the software component that enables the network access for the device. This is a simple information about the resource. Coming to the next important one, service. Here, how can you represent the service here? Service provides an interface for interacting with the physical entity. Here, for example, there is a physical entity is there. Let us assume the physical entity represented as a rectangle box. What is the service here? The service provides an interface for interacting with the physical entity. It is an interface between a physical entity and that information, just like a medium. Not a medium here, it is a some type of service, threshold service, like that different services are available.
The service access the resources hosted on the device, the network resources to obtain the information about the physical entity. This is a certain information about the different services existed in this entity. And then coming to the next information, the fourth step in a design methodology, information model specification. Here, what is a information model specification? The information model specification defines the structure of all information in a IoT system. The data structure of all information in a IoT system. The structure in the sense, for example, it defines the attributes of virtual entities and their relationship. For example, let us take simple example, employee. The employee attributes employee number, employee name, employee salary. These are all different attributes of a employee. That means in this case, you will defining the corresponding room virtual entity, corresponding appliances virtual entity. You will defining the what you are defining the structure. The structure, that means that is a simple information about the information model. Here, this particular information model does not describe the specific how the information is represented or stored. How the information is stored. You are not specify the how information is stored. To define the information model, first list the virtual entities defined in a domain model. What are the virtual entities here? That means how can you represent this virtual entity? That means based on a physical entity, you will identifying the virtual entity. The information model adds more detail to the virtual entities. That means why? Because for particular physical entity, there exists a attributes. There exists the relationship between a different attributes. For that one, that means you will get the more detailed information. That is a drawing a class diagram is a information model specification. Like the class diagram represented where you are representing this particular class diagram in the object oriented analysis, you will represent class diagram. Here also you will represent this information. And then coming to the service specification. What is the service specification here? Here, this particular service specification defines the services in a IoT system. Here, the what are the services, the service type, the service input or output, service endpoint, service schedules, and then service preconditions and their effects. That means you will represent a service specification and precondition for this one. And then the service can be control service, sometimes threshold service, state service, mode service, and then services, different services are there, control services. These services either change the attribute value or state or retrieve the current value. That's called here the service specification, a simple representation. Coming to, for example, in case of irrigation system, the threshold service sets the signal to high or low depending upon a soil moisture value. And then state service, there is another service, state service, sets the monitor state on or off. The control service is a one type of service, monitor the threshold value as well as the monitor motor state and switches the motor on or off and update the status in the database. These are all different services. We are coming to the sixth step in this design model. The sixth step is a that means this is a IoT level specification. That means in the unit one, you discussed about the IoT design is different IoT level for the system. What are the different levels? That means you define the 6 IoT different levels. The what are the IoT level one? If you need, I can explain you here. IoT different level. Yeah, in the presentation PPT, not a PPT, in the video number 8. In the video number 8, we discussed about the different levels and deployment templates of IoT. If you need, I can explain it clearly now also. Here these are all different levels and deployment templates. That means based on a levels and you have a 6 different levels are there. That means if you want to process those levels, but each and every level having these components. What are the component? Device, resource, controller service, database, web service. These are also controller service as well as the web service, analysis, component and application. These are all different components for accessing these level. For example, device. Here, what is the device? Device allows a identification, remote sensing, activation, and remote monitoring capabilities are there. Coming to the resource, already discussed, resource is a software component on an IoT device. This is a simple software component for accessing, processing, and storing the sensor information and controlling the actuators connected to the devices. This is a simple software component. And then the resource includes a software component that enables the network for the device. Coming to the controller service. What is the controller service? The controller service is a native service that runs on a device and interact with the web service. It is a native service. Here always the service used to interacting the web service. The controller service sends a data from the device to web service. That means, for example, there is a controller service is there. There is a web service is there. The controller service always sends a data to the web service. That means device to web service, and then receives a command from the application. Here, why? Because if you go to the level one, you can understand what is the control service. The control service, the work of controller service always sends a data from the device, sends a data from the device to the web service and receives a command. For that purposes, you are using the control service. And then database, either that means it may be a local database or it may be a cloud database. Store the data generated by the IoT device. And then web service. The web service is what can you represent link between a IoT device and application. The database and analysis component. Web service can be either implemented using HTTP and REST principles. That's called here REST service, or using a WebSocket service. That means in the seventh, sixth video, I explained about the different REST service and WebSocket service. And then analysis component. Here, how can you represent analysis component? For analyzing the IoT data and generate a result in the form of, in the form easy for the understand. The application provides a interface that user can use to control and monitor the various aspects of a IoT system. The application also allows a user to view the system state and to view the some information. Here, the level 1 IoT system. How can you represent this level 1 IoT system? Here, in this case, the level 1 IoT system consists of devices, resources, controller service, as well as the REST and WebSocket service. That means you discussed each and every property, databases, and then applications are there. That means everything exists in a local machine, not in a cloud. Why? Because it is a small, that means the IoT level only have a particular node or device that perform a sensing. This is called here any device, Raspberry Pi or something here else. Here for sensing the data, activating the data, for doing that one, you will use a device. That means IoT level 1 systems are suitable for the low cost and low complexity solutions. These are all, that means not using the cloud. So if we have the data size is very large, then you will go to the cloud. Here, low cost, low complexity, where the data involved is not big. Here, the small data sets or the small data sets and the analysis requirements are intensive. That means computationally intensive. Then particular cases, you will use this system. That means I'm telling you some information about the level 1. Stored locally, done locally, and then mobile app and web application. That is a simple information. Coming to the, for example, home automation system is the best example for this one. And then level 2, we will store data in a cloud. Will you identify the difference? Level 1. In the level 1, everything exists in a local. Here you will store the data in a cloud. For example, this one is the data. That means, for example, smart irrigation system. The smart irrigation system is the best example. And then level 3, computationally intensive. The computation is very low. This particular similar to the level 1. And then in this case of level 4, level 3 is a tracking package handling. Level 4, if you go to the level 4, the level 4 having a multiple devices. The not a single device. Up to now, single device is there. Multiple devices. There is a observer node. There is a observer node for the REST service. Oh, that is a difference here. That means everything. That means some of them, some data stored in a cloud, and then application is a cloud-based application. But there exists a observer node. This particular observer node in a level 4. It's a noise monitoring system. And then level 5. Here in the level 5, there is a multiple nodes are there. There exists a coordinator device. One extra device existed instead of ordinary endpoint devices. There exists a coordinator device, and then observer node is there in a level 5 coordinator device. This particular coordinator device is a one type of device. This particular coordinator node collects the data from the end nodes and sends to the cloud. For this purpose, you will use the coordinator node in a level 5. This particular system is applicable for the forest fire detection. The forest fire detection level 5. And then coming to the level 6, there exists a controller. That means centralized controller is there, and then observer nodes are as usual. That means multiple nodes existed, and then there exists a centralized controller, and then observer node is there. That is the main difference between these level 1, level 2, level 3. For example, weather monitoring system is a best example. This is some information regarding these particular levels. I think it is clear for you. These are all different IoT system specification levels. The functional view specification. This is a seventh step in a design methodology. What is this functional view specification? The functional view specification, the functional view defines the functions of IoT system. The grouped into various function group. See here, the functional view defines the functions of IoT system grouped into various groups. Each functional group either provides a functionality for interacting with the instance of concept, define a domain model, or provides information related to this particular concept. That is the functional view defines the functional groups. For example, the functional group included in a functional view includes the functional groups consist of these components. What are the components? The functional group, this particular functional group consists of these components are there. The components may be, one is a device, other one is a communication, and then service, management, security, finally application. These all are the functional group component. The very important functional, these are the functional group components. The next thing here, advantages using. Before that, there is a function. These functional groups includes the functional view. That may be, for example, one is a device. The device, an IoT system consists of devices. In particular, devices provides a sensing. These particular devices provides a sensing, activation, monitoring, and controlling functions. The particular devices sensing, activation, as well as the controlling. Sensing in the sense, the sensor always takes a input from the environment. That means it takes a physical input, physical parameters, and then convert it into digital format. Activator, the reverse process of the sensor is a activator. The activator always takes a digital form of data, converted into physical parameter. Best example, water motor. From the electrical format of data converted into water. And then control functions are there. These are all different information. In the home automation system, you have a different activator, that means different functions. For they include, say, the single board mini computer, light sensor, light dependent sensor, and then relay switches. For this one, these are all different functionality. Communication, the next important one, communication. The second part here, the communication. What is the communication? The communication handles the communication for the IoT system. In the home automation system, the communication protocols include, say, some of the protocols are there for performing this particular communication. These are all different protocols. And then communication model. And then services. The very important one, services for device monitoring, device control. That means some of the services are there. The services for the device monitoring services, device control services, data publishing services, the services for the device discovery. Like that, you will have the different services are there. That means these may be defined by using REST services. For example, the home automation system, different services. And then management, various functions to count the IoT system. That means this block provides a various function to govern the IoT system. To manage the IoT system, we will have a different function. It will include all functionalities that are needed to configure and manage the IoT system. And then security. The security, that means this block of securities, the IoT system, and by providing a function such as a authentication, authorization, message, that means content integrity, data security policies are there. That means the security means unauthorized person cannot access our data. For that purpose, authentication, other authentication and authorization capabilities, providing finally there is application block. This is the interface that the user can use to control and monitor the various aspects of a system. That means application provides a user interface. The GUI is a very important one. From the GUI, the user can use the control and monitor the various aspects here. Application allows user to view the system status and then to view and analyze the processed data. For viewing and analyzing the process data, you will have the different application. That is a seventh step. And then coming to the eighth step, operational view specification. Here, what is an operational view specification? In the operational view specification, various options pertaining to the IoT system development. Various options. The operations are defined such as service hosting options, the storage options, device options, application hosting options. Like that, you will have the different options available in this system. That is a operation. Finally, the device and component integration. The ninth step in IoT device methodology is the integration of devices and component. For example, in case of home automation system, you will have the devices may be IoT device. It may be Raspberry Pi sometimes, or sometimes you may use a Arduino kit, or the components may be some of the sensor, some of the activators. That means like that, some of the software components, web-based service components, like that. You will have the different components. That means you should all integrated in a one certain place. And then finally, there is application deployment. This is a final step. To develop an IoT application, you will use this step. Here, you will implement the programming. That means if you use a Raspberry Pi, we will implement the programming by using Python programming language. Okay, these are all different steps. Next, you will discuss about some of the advantages for this one. What are the advantages using this design methodology? Reducing the design, testing, and maintenance time. You are going to reducing this information, and then provide a better interoperability, and then reduce the complexity. This is some information. Next, we will discuss about the how to design a home automation system case study. Thank you. In the previous session, we discussed about the design methodology 10 steps. Now, you are going to know about the case studies for the home or in the case studies home automation system by using this design methodology. The home automation systems case study. In this home automation system case study, you are going to know about the controlling of light in a home remotely using a web application. That means by using mobile phone or we will our automatic sensors, we will control the our home system. The next important thing, that means you will apply these 10 steps for the home automation system for controlling the light levels. The first important one, the purpose and requirement specification. The previous session discussed about the purpose and requirement specification. That means in what purpose you are going to designing the system. Here, the purpose of the designing a smart home system is a home automation system is a allows a controlling of light, the controlling of light value, the controlling of light in a home. That means it is a low level or high level. It depends upon any criteria. That means you will controlling the light level remotely by using web application. That is the main purpose for the controlling the light level or home automation system. In this system, the behavior, the home automation system behavior, we have two different modes are there. One is a auto mode, other one is a manual mode. Auto mode means automatically if light level is low, automatically you will switch on the light. If light level is a high, you will switch off the tube light. That is a depends upon a light level, you will stop or start the lights. In the auto mode, the system measures the light level in a room and switch on the light when it gets dark. That means room level is a dark, automatically switch on the light. In manual mode, the system provides a option for manually and remotely switching on or switching off the light. That is a main intention for using these levels. In this they have a the requirement. What are the different requirements here? System management requirement, data analysis requirement, application development requirement, and then security requirement. In the first case, the purpose and requirement specification. The system requirement, the system management requirement should provide a remote monitoring and control functions. And then data analysis requirement. If you come to the data analysis requirement, what about the exactly data analysis requirement? That means it perform the local analysis of data. That means you are getting the, after collecting the data, you have to perform some analysis on data. That means what are the different rows for this one, and then what are the different attributes of the system, and then how can you process this attribute, and then how can you provide a missing values for this one. That means everything existed in a data analysis. The next important one, application development requirement. Here the application development requirement should be deployed on a device but should be accessed remotely. And then the security requirement, the security in the sense authorization and authentication purposes. The system should have basic user authentication capability. That for the purpose you are using the this first step. The first step over. Coming to the second step, process specification. In this process specification, you have to design the use cases for the IoT system. That means you have to define the some of the actions for this system. What are the actions here? How can you represent these actions? Here the process with the help of use cases. Here the use cases may denote the a simple circle or it may be attribute. In case of home automation system, how can you write the use cases? In the previously, that means how can you get the use cases? You will get the use cases from the purpose and requirement specification. From the purpose and requirement specification, you will get these use cases. In the first step, you have the system performing, the home automation system performing two different mode. One is a auto mode, second one is a manual mode. Here, when you are using the auto mode, if the system is in auto mode in the sense, if then it will identify the light level. If light level is a, it's for example dark light, that means the room temperature is a dark, then the state here is a switch on the light. That means you are going to switch on the light. If light level is a high, that means there is a light in more intensity value is there. Light is a high. Then this particular case is, how can you represent that value? You are representing that value is a switch off the light. And then coming to the, if you comes to the manual mode, here how can you represent the manual mode here? The light state depends upon a light state. The light state is a on. The light state is on. That means you are going to on the state. And then the state of the light is off. That means you are going to stop the light. That means in order to doing this one, that's a depends upon this information. Here in this case, you have a circle is there. What is, how can you represent the circle value? Circle is a start of the process. Here in this case, this particular circle you are represented as a start of the process. The next important diamond, for representing the process specification, you will take the diamond in a IoT system. Here, how can you represent diamond here? The decision box. You will take the in the home automation system criteria, either you will take the decision auto mode or manual mode. That indicates the decision box. And then coming to the rectangle. Here, if it comes to the rectangle, how can you represent the rectangle here? It is simply attribute, or it is simply attribute or state. The state or attribute value. Here in this case, the auto mode, for example, the state, the mode is a auto mode. How can you represent the mode here? The system monitors the light level. It is a auto mode. Then the system identify the light level. Here, if light level is dark, the light level is a dark. The system changes the state of the light to on. The system changes state of the light to on. If light level is high, that means in the room the light level is high. The system changes the, it's a off. That means it's going to off. Coming to the manual mode. If when the manual mode is selected, here the system verify the light state of a, the light state set by the user. That means you will set the light state. You will set the light state by the user. Here, how can you represent that one? If light state set by the user is on, here the system changes the state of the light in a room on. Here, if the system state set by the user is a on, the room state is also a on. If the light state set by the user is off, if the state of the room is a also off. In this way, you will identify the, that means this is a way of representing the specification for this particular home automation system, for identifying the, in the particular home automation system, the smart lighting system of a room. So for doing that application, you will do this one. The second important component in this case here is a domain specification, domain model specification. In the previously discussed about the domain model specification. The domain model specification provides an abstract representation of concepts, objects, entities in a domain. That means it's a understanding the IoT domain for this system to be designed. And then in this case, it defines the attributes of objects and their relationship. In the next one. Here, the entities, objects, concept include the following. The following are the very important things here. One is a physical entity, virtual entity, device, resource, and then service. That means the concept entities include the this information. Here in the domain model, what is a physical entity? For example, room is a the real world. That means discrete identifiable entity in a physical environment. That's called here a room, a pump, motor, LCD. Everything, the entity call it as a physical entity, the physical appearance of an entity. In the IoT system provides the information about the physical entity using sensor or perform the activation upon the physical entity like a switching a motor. That means this is called here, for example, in the home automation system, room is a physical entity. Appliances is a one of the physical entity. Coming to the virtual entity, the physical entity room, the representation of room, the representation of physical entity in the digital world. The representation of physical entity in the digital world is called as a virtual entity. For example, for each and every physical entity, there exists a virtual entity. For example, the representation of room like this, the virtual entity. And then device. How can you represent this particular device? The device is an interaction between a physical and virtual entities. That means it takes the physical information. For example, sensor. Sensor takes a physical parameter converted into which type of digital form. Here, devices are used together in form from the physical entity. Devices are used to identify the physical entity using tag. Here, this particular sensors also used to identifying the physical entity. For example, physical parameters. In coming to the resource is a software component. You discussed that one for accessing or processing or storing the sensor information. The resource includes a the software component that enable the network access for the device. This particular is a resource. And then service. What is a service here? The service provides an interface for interacting with the physical entity. This particular service provides a interface for interacting with the physical entity. The services access the resource hosted on the device or network resources to obtain the information about the physical entity. Here, this is a domain model specification. What is this particular domain model specification for the home automation system? One thing you have to know, one way, for example, the arrow indicates the one-way association. This particular arrow, filled arrow indicates the generalization or specialization. This indicates the aggregation. Part of whole. In the object-oriented analysis and design, you will identify this information. See here, here in this case, you will identify that these are all physical entity for the home automation system for controlling the light level. These are all virtual entity for the home automation system for controlling this one. And then there is a service is there. You have a mode service, controller service, and then some of the different services available. The resource is a software component. Here, resource also available. That means device. That means in this case, in this way, you will have the some certain kind of information. The first thing here, I am going to starting from the particular user or device or anything here. Here, for example, the physical, I am going to starting from physical entity. Here, this particular physical entity, what is the physical entity? There is a representation, the virtual entity related to the physical entity. The representation of physical entity room. Room is a physical entity. The representation of physical entity is a this one, the virtual entity. These are all appliances for the virtual entity. And then the virtual entity associated with the service. Here invoke the different services are there. This particular service exposes the resource. That means service exposes the this particular resource or this particular virtual entity associated with the this particular resource. The resource may be network resource or resource may be, that means there is a generalization is there, the generalization concept. That means general parent to child relationship, the on device resource. This particular is a on device resource. This particular on device resource host on a device. That means the aggregation, it is a part to whole relationship. The relationship, part to whole relationship, we call it as a aggregation. The device having the on device resource, and then this particular device attached to activation, or this particular device attached to sensor. This particular LDR sensor, light dependent relay sensor. Here, this particular light dependent relay sensor monitors the physical entity room. The sensor monitors the physical entity room, and then activator relay act on the appliances. Activator room act on the appliances. That means in this case here, the user interact with the physical entity. That means always the user always interact with the this particular physical entity. In this case, human users are there, active digital artifacts are there. This is a some domain model for this specification. And then coming to the in the particular domain model, there are three services are there. Here, what are the services here? A service that set mode auto to manual. That's called here mode service. A service that sets a light appliances state that to on or off. That is called here state service. And then other third important service here is a the controller service that run as a native service on the device. These are all three different services. If you see here, the services may be three different services existed for this one. And then coming to this one, when in auto mode, when the controller service monitor the light level and then switches the light on or off, and then update the state status database. And then if it is in a when in a manual mode, the controller service retrieve the current state from the database, switches the light on or off. The process of deriving services from the process specification information modeling described in the next section. That means from the process and driven. And then coming to the next fourth important information here is a information model. How can you represent this particular information? Previously discussed that one here. In the information model, you will identify the attribute for the virtual entities and then their relationship. The attribute for the virtual entities for the relationship. Here, this is a very important task. That means, for example, in this case here, you will identify. That means design the class diagram in this case. Previously, designed a entity relationship diagram. Here, in this case, you will define in the different attributes for the virtual entity. The virtual entity room. These are all are the room attributes. That means a property of an entity called as a attribute. Here, the virtual entity light appliances. The light appliances attributes. These are all are the attribute. That means you will identify the attribute level is a one entity. That means in this way you will identify the attributes as well as their relationship that indicates the information model. For the home automation system also you will identify in this way. And then in this information model here, two virtual entities are there: virtual entity light appliances and then virtual entity room. This is a information model. The next service specification model. This is a simple information regarding the information model. And then service specification. This is a one of the step in the service specification. Define the services in an IoT system, service type, service input, and then service endpoint, service schedules, and then service preconditions, and then service effects. That means you are going to defining the all information in a service model. The very important thing in this case here, you have to map the process specification model with the information specification model. Here there is a mapping is there. In this case, we have a three different services available for the home automation. In case of home automation system, three different services for the mode service. Other one is a state service, that means for setting the state level, and then finally you have a controller service is there. The controller service is one of the service for this one. Here come to the first one, mode service. Here how can you represent this particular mode service? In this case, the mode service sets the mode to auto or manual. Auto or manual or reduce the current mode. That means you are setting this is a one particular service. And then coming to the state service. Here, the particular state service indicates that state sets the light appliance state to on or off, or retrieves the current light information. Finally, the controller service, one of the important service in this in auto mode, the controller service monitor the light level and then switches the light on or and update the status in the status database. That means it is verifying that the controller service. What is the controller service here? Monitor the light level. That means based on the light level, either dark or full light, based on that one, you will have the switch on or switch off the light and then update the status information in the database. And then in the manual mode, here coming to this particular manual mode, the controller service retrieves the current state from the database and switches the light on or off. That means for doing that one, you have a different services. These are all different services. That means you will discuss the services in this case. Process, that means in this deriving the services from the process specification and information model. And then process specification and information model, you identify the state and attribute. For each state and attribute defining the service. That means this particular attribute, this may be state or attribute. The rectangle indicates that state or attribute. For this particular state or attribute, this particular attribute you will define the service. And then for example, for mode service and then light state service. Light state for this one, attribute state or light state, you will defining this one. Another attribute here is the controller service. This particular controller service. These are all different services. That means based on that one only you will define the state service. What is the state service? How can you represent? You discuss those information. And then in manual mode, how can you represent this particular state service? Here these services may be three different services you have. One is a controller service, other one is a mode service, other one is a state service. You discussed those concepts. That means you will discuss here again one by one. Here the above diagram shows that three diagram shows that the controller mode and these state services. And then coming to the controller service, how can you represent the controller service? The controller service run as a native service on the device. This particular controller service, when in auto mode, the controller service monitor the light level and switch on the light value and update in a database. Update this information in a database. That means this is an input, and then we will get this one is a output. That is when it is in a manual mode. We discuss that information. What is that information? Retrieves the current state of the database and switch off or switch on the light. And then other mode service. Mode service indicates that this service is a mode service. How can you represent? Is a REST full web-based service. That means this particular service sets the mode to auto or manual. The mode updates to the database from this one. And then coming to the last important service, here is a state service. Here REST full web service. This particular service light appliances state to the on or off. That is called here put request. And then retrieves the current light state. That is called here get request. That means based on this information, we will have the state service. Coming to the IoT level specification, you have a 6 levels in the unit 1. That means if you want to see video 8, the 8 video I specified different levels for the IoT system. The IoT level specification, you have a 6 levels are there. Here in case of home automation system, I used a one first level. That means this particular first level That means everything existed in a local. That means not in a, for example, device. That means you will take the Raspberry Pi, Arduino, and then resources, the software component, controller services, databases, and then REST services. That means the application also a local. That means it's a level one service. Monitors the node performance analysis indicates that level one service. The diagram shows the deployment level of the which is a level one. The deployment level of a home automation system, it is a level one. And then coming to the functional view specification for the home auto. In the previously discussed functional view specification, function of IoT system grouped into various functional groups. Here this particular each and every function group having the this particular component. You discussed those devices, communication, services, management, security, and then application. Here, device in the sense for a sensing, activation, and monitoring. For this purpose, you are using the devices. In case of home automation system, the device functional group includes a single board mini computer. For example, that is a Raspberry Pi. Single board mini computer is a Raspberry Pi, and then light sensor. This particular light sensor is a one type of device, and then relay switch activator. The relay switches activator is a one type of device. These are all are the devices in a home automation system used. And then coming to the communication. How can you handle the communication? Communication between a different components of a IoT system. In the home automation system, the communication protocol includes 802.11 in a link layer protocol, and then IP version 4 or IP version 6 network layer protocol, and then HTTP application layer protocol. That means you will use these number of protocol for implementing or for designing the home automation system. The communication API used in this example is a REST based API. And then services. Coming to the very important one, this is a services for device monitoring and do device control and control service, and then services for the data publishing, services for the device discovery. These are all different services available. In home automation system example, there is a two REST services, mode and state services, one native service, the controller service. That means you discussed those services, RE mode service, state service, and then controller service. Management. That means how can you represent this particular management? This block provides a various functions to govern the IoT system. This block, and then it includes the some of the functionality that are needed to configure the configure and manage the IoT system. Here this coming to the security. Here how can you represent the security? Any unauthorized person can access our data. That is a security reason. Application. This is an interface that user, that means graphical interface that user can use to control and monitor various aspects of a IoT system. This is a graphical interface here. Application allows user to view the system status and to view the or analyze the processor data. This is a functional block information. You are linking the IoT level to level 1 system to different functional block devices maybe. That means used devices, Raspberry Pi, activator, mini computer, and then the resources maybe. In this way, you will link all these information. Coming to this particular functional group. That means you have to explain, for example, IoT device map to the device functional group. How can you mapping this one? And then the second important resource map device to functional group. How can you map this one? And then third important controller service map to the service functional group, native service. How can you map this particular service group? That means in this way you will map the all information to different functional group. This is a functional group. And then operational view of a view specification. Operation view specification, various options pertaining to IoT system management, system deployment operations are defined here. Here, the service hosting option, the service storage option, device option, application hosting option. These are all different options. In this case, you have a different options available here. For example, for this particular devices, the computing devices may be options Raspberry Pi, and then sensor may be LDR sensor, light dependent sensor. That means relay switch. This for particular devices. Here coming to the communication. When you perform the communication based on a REST API, the communication protocols available here 802.11, and then IP version 4 and IP version 6, and then transport layer protocol TCP, and then application layer protocol HTTP, hypertext transfer protocol. These are all communication layer protocol. Here coming to the services. Previously discussed the different services. The native services, web services. The native services may be controller services, and then web services may be mode service, and then state service. The mode REST service, state REST service. These are all communication. Coming to the management, that means governing the application management, Django application management, and then database management may be MySQL database management. The device management may be Raspberry Pi device management. Here in this case, you will perform in the Raspberry Pi device management. And then coming to the security, authentication. How can you perform the authentication? Web app and database. Authorization, web app and database for this security group. And then finally application, that means this is a graphical user interface for accessing the different aspects of a system by using this one, the application, web apps, application server and database server. The web app indicates the Django web app, and then application server is a Django application server, and then this particular database server is a MySQL. This is a operational view specification. This is some information regarding the operational view specification. Finally, you have to integrate all these components. The components may be devices, sensors, Raspberry Pi. That means Raspberry Pi. If you use the Raspberry Pi or mini computer or activators, you have to interlink these information into different resources. Resources may be software components. That means different components are integrated in this step. Finally, that means in this way you will integrate all these components in a one place. And then this is a some information in this information. Raspberry Pi is a mini computer. The Raspberry Pi is a mini computer, and then LDR sensor, light dependent sensor. LDR sensor used, and then relay switch. One relay switch used for switch on and off the light, and then detailed description of Raspberry Pi board and how interface sensor and activated board is. That means we previously discussed the concepts. And then final step in the IoT design methodology is to develop a IoT application. That is you will developing some application for that one. Based on it, that means you wrote some code that the implementation. How can you perform this particular implementation for doing that one different modes and models? How can you performing? This is some representation of the system. This particular representation for this one, these are all references. The reference textbook, very simple and important textbook. And then not only this one, you have some web documentation available. Okay, thank you.